Hey guys, welcome back to another science lesson with HKR Math and Science. This video will be about seafloor spreading. So the learning intention for today is to explore the concepts of seafloor spreading and Hess's theory. And by the end of this lesson, we should know the concepts of seafloor spreading, be able to explain seafloor spreading, and finally know and understand the three important pieces of evidence that support Hess's theory. These are magnetic striping, seafloor age, and sediment thickness. So just pause the video here and take a couple of minutes to write these down. Alright, let's start with how the theory of seafloor spreading came about. So in 1872, scientists were surveying the ocean floor to set up an undersea telephone cable between America and Europe. They measured the ocean depth by dropping down very long cables and measuring the length. And in the middle of the Atlantic Ocean, they discovered a very long and large ridge, which is a long narrow hill. So we have an example of a ridge here, so that middle part there will be known as a ridge. So they found this stuff in the ocean as well. And in 1925, it was found that this ridge ran the entire length of the Atlantic Ocean. After 1945, further studies found that the underwater ridge continued into other oceans and around the Earth, as we can see in this image here and the one over here. So you can see the ridges go all around the Earth. In 1953, scientists further found that the ridges had a series of huge cracks along them. So let's have a look at this ridge here. Just imagine there was a huge crack down the middle. That's what scientists were finding down under the ocean. These cracks are called rifts, and so the system was named the Great Global Rift System. So all these ridges here, and rifts, this was then named the Great Global Rift System. So this brings us to seafloor spreading. In 1962, an American geologist named Harry Hess tried to explain what was happening at the ocean ridges. Hess proposed that new rocky crust was being formed at the ocean ridges and spreading outwards. So if you guys think back to year 8 science, you remember that igneous rock is formed by magma cooling down. So in this ridge here, Hess said that magma is flowing out of the ridges, and as it flows out into the ocean, it cools down to form rocks, and these rocks were spreading outwards from the ridges, which is known as seafloor spreading. So you can see that depicted in this GIF here as well. All the rocks that flow out of here cooling down are spreading outwards from the ridge there. So pretty much this whole process is known seafloor spreading. So that's the main point behind seafloor spreading, but that's not where it quite ends. Hess further proposed that the crust was sinking down into the earth, forming ocean trenches. So we can see that in this image here. The crust is on the top and it gets pushed down into the layer below it. As the crust sinks, it melts and is destroyed, and this process of the crust sinking down like this is known as subduction. So the theory behind seafloor spreading is often known as Hess's theory as well, and Hess's theory of seafloor spreading is supported by three important pieces of evidence. These are known as magnetic striping, age of the seafloor, and sediment thickness. Alright, so let's start off with magnetic striping. This one might be a bit of a hard concept, but to start us off, we need to know that many rocks contain the magnetic iron oxide mineral called magnetite. So magnetite has a north-seeking pole and a south-seeking pole, just like a compass needle. So if you can see this image here, this needle will always point towards the north. It's always going to where north is. There's particles inside magnetite that does exactly the same thing. When molten rock solidifies, all the magnetite particles in it line up with Earth's magnetic field to point in the same direction. So when it solidifies, it preserves the direction of the Earth's magnetic field at the time. Alright, so just to clear that up a little bit, when molten rock is in a liquid form, so magma, the magnetic particles in it can move around like the compass needle here. However, when the molten rock solidifies, the magnetic particles will stop just like that, and the particles will all line up with the Earth's magnetic field to point north. So this captures the Earth's magnetic field at the time. So the direction of the magnetic field isn't visible to the human eye. You need something called a magnetometer. And geologists found that as they went away from the ridge, the magnetic field preserved in the rocks kept changing, and there was a pattern which was in strips like this here. So this happens because Earth's magnetic fields flip around every few million years, and as Earth's magnetic field changes over the many million years, so did the magnetic direction preserved in the rock. So as the magma rises up out of the ridges, so through the middle here, rock is added to each side as it cools, so new seafloor is being added equally on each side, which is why the pattern of magnetism is symmetrical. Like you can see in this image here, it's the same on either side. So this symmetrical pattern of magnetism supports Hess's theory of seafloor spreading, as it could have only happened if the new rock formed at the ocean ridges was spreading outwards like this here. Alright, so now to look at the next piece of evidence supporting seafloor spreading, we're going to have a look at the age of the seafloor. So scientists found that the further the rocks were from the ridges, the older they were. This is because new rocks form near the mid-ocean ridge and move outwards and away from it. So once again, this can only be explained through seafloor spreading as new rocks form at the ridge and they get moved away. This is why these ones are older and the fresher rocks will be in the middle. Now moving on to our final piece of evidence, sediment thickness. This one states that the sedimentary rock layers on the ocean floor become thicker as you move away from the ridges. So in this image here, this means that from the ridge in the middle, the further you go away from it, the thicker the sedimentary rock layer is. This is because sediments on the rocks on the seafloor furthest away from the ridges have been falling for longer. So let's pretend this triangle is a hill here. If you think about it, if rocks keep coming out from the center here, they're going to eventually fall down. They're going to keep falling down here. And the further you get, so towards like the bottom here, you're going to have more rocks because they're just going to keep falling until they stop. So the further away, you're going to have more rocks, and the closer you get to the ridge, you'll find you'll have less because they would have traveled down by now. So the fact that there's more sedimentary rocks further away from the ridge supports seafloor spreading because it's saying that the rocks are being pushed down like that. Alright, just a final recap on seafloor spreading. So seafloor spreading is when magma flows out of the ocean ridges and it forms into rock and it is being spread outwards from the ridges. Alright, so now that brings us to the end of this lesson. Hopefully you guys do know a bit more about seafloor spreading now, and you guys know the concepts of seafloor spreading, can explain what it is, and finally know I understand the three important pieces of evidence that support Hess's theory of seafloor spreading, which are magnetic striping, seafloor age, and sediment thickness. Thank you guys for watching, and I'll see you guys all back online.